So we also have the definition of linearly dependent. So the vectors v1 to vk in a vector space V are linearly dependent if they are scalar c1 to ck not on zero, such that c1 v1 plus ck vk equal to 0. So this just means that this system has a non-trivial solution, right? So this is a system if we are given on the vector v1 to vk, and we need to check whether they are scalar c1 to ck not on 0, such that we have this equality. This just means we have a system with variables c1 to ck, right? And we want to check whether they exist non-trivial solution c1 to ck not the vector 0, such that we have this equality. Now we check with the two vectors. So again, we start by considering this linear combination c1 v1 plus c2 v2 equal to vector 0 for c1 and c2 in the set of real number. Okay, in this system, let me go star. So star is equivalent to the system writing in terms of matrix 1 1 2 2 c1 c2 0. And yes, so usually for like this is easy case, but usually you can just do Gauss-Jordan elimination to do that. So 0 2 minus rho 1. And for this example, it is easy, so we can see the solution immediately. But so I write augmented matrix. So you usually we do like this, and there are 3 variables, right? There is a 3 variables by saying C2 equal to alpha. So we have the solution is this system is correspond to C1 plus 2 times C2 0 and C2 we can just put equal to alpha, right? 0 equals 0. So C1 minus 2 times C2 minus 2 times alpha. So we can say that the system star has so non-trivial solution. It's A, or it's at least one. There are a lot of infinitely many non-trivial solution, but we just say one is enough. Trivial solution. Say minus 2 and 1. Right, minus 2 1. Therefore, by definition, there exists C1, C2 not on 0, right? Such that this equalities holds. V1 and V2 are linearly dependent. Okay, so again, this question is only for 2 by 2 matrix, right? And we know that this matrix has a non-trivial solution. It's a square matrix has a non-trivial solution. So recall that Weber theorem saying A is a square matrix and by n. Recall A subside n by n is invertible if and only if the system A is x equals 0 has only retrieval solution. Right. And we also know that this one is invertible if and only if the determinant of A is non-zero. Right. So now we have, this is the same thing as saying A is singular. We negate both statement or even the three statement is singular or non-invertible, right? If and only if determinant of A is 0 and equivalent to AX equals to 0 has A or at least one non-trivial solution. Right. So, okay, now we check that this matrix A in our case is 1, 1, 2, 2, which is obviously singular. Determinant of this is 0, right? So in our case, A is a matrix 1, 1, 2, 2. Determinant of A is 2 minus 2, which is 1. A is singular. And hence the system AX equals 0 has trivial solution, a non-trivial solution. Yeah. Therefore, we know that okay, there exists something that's non-trivial, so that this system or this linear combination is still true. Therefore, by definition, they are linearly dependent. Two vector 1, 1 and 1, 2 are linearly dependent. Yeah, 1, 1, 2, 2 is right. In fact, we can see in this example it's super easy because this second vector is just 2 times of the first vector, right? So just one vector is enough to span the whole span of the two vectors, right? It's the same as span of this one. This one is depend on this one because this one is just 2 times the first one, right? Or we can say, okay, I can use this vector because this vector can be represented as a half of the second vector. So use one vector is enough. Therefore, they are linearly dependent.